Let's show that these functions satisfy the wave equation. For that, let's recall what is a wave equation. That's the second degree partial derivative of the function by x that equals 1 over v squared, the partial degree second degree partial derivative by t. Let's call this equation 1 and start taking the derivatives, partial derivatives for y. I'm going to start with the first equation. So d dx yxt should equal a over x plus vt, and then take the second derivative of that, d 2y dx2 would be, I'm taking the derivative of my answer, that would be d dx a over x plus vt, which equals negative a over x plus vt squared. Now let's take the derivative by t. Partial derivative by t, d dt yxt equals a v over x plus vt. Taking the second degree derivative of this function by t, that is to say d dt a v over x plus vt, and that will give me a value of negative a v squared over x plus vt squared. Now let's plug this in, our second derivatives in equation 1, and see whether it is making any sense to us, if it satisfies or not. So negative a over x plus vt squared, and we're interested if this is actually equals to 1 over v squared negative a v squared over x plus vt squared. Well, if we do a little bit simplification, we see these v squares cancel out, and then we end up having negative a over x plus vt squared on the left side, and on the right side we have negative a over x plus vt squared, which is equal to each other. Therefore, yes, it satisfies, this function satisfies the wave equation. Okay, now let's try to do part B. Although you could stop right here and then try on your own to do part B, but I'm gonna continue. So let's choose a different color. Okay, so as we did in a previous case, let's take a derivatives. First, the partial derivative by x of x minus vt to the 4, which equals 4 times x minus vt to the 3, and then the second derivative of that one would be 2d2y dx 2 equals d dx 4, let's just do a square parenthesis, 4 x minus vt cube. Okay, so that will give us 12 x minus vt squared. Now let's take the derivative by t, partial derivative. So d dt x minus vt to the 4 gives us negative 4v x minus vt cube. Now the second degree second derivative by t would be d dt negative 4v x minus vt cubed, that equals 12v squared x minus vt squared. Okay, so we're gonna do same thing, plug it in equation 1. Then we will have on the left side dy dx squared will be 12 x minus vt squared, and we're interested to see whether this one equals to the right side, which was 1 over v squared 12v squared times x minus vt squared. Well, the v squared cancel out here, and we can see that the left side and the right side are equal to each other. X minus vt equals 12 times x minus vt squared. Okay, so yes, this one also satisfies the wave equation. Thank you for watching. Stay tuned for more problems to come. Just want to add a small correction. I forgot to put a 2 right here. I hope it didn't confuse you.